In this video, we'll talk about integration by parts. So let's review the product rule for differentiation. If you have two functions, u of x times v of x prime, it's u prime of x times v of x plus u of x times v prime of x. Now, if we integrate both sides of this equation that I highlighted here, we're going to get integral of u of x times v of x prime, which is actually u of x times v of x. It's integral of u prime of x times v of x dx plus integral of u of x times v prime of x dx. So by writing this relation, if we rearrange the terms and we write this term, we leave it on the right hand side and we move this term here, we're actually going to get integral of u of x times v prime of x dx. It's u of x times v of x minus v of x times u prime of x dx. Or we could have it like integral of f prime g dx. It's equal to f times g minus integral of f g prime dx, where f and g are functions of x. So also another renotation of the terms. If we take this term of v prime of x dx and we write it dv, we can write it in this format: integral of u dv, it's uv minus integral of v du. So let's do a few problems. We have integral of x cosine of x dx. So if I want to use this format that we have here, let's figure out which one is our u and which one is our dv. So u, it's equal to, let's write it like this, u dv. U, it's equal to, well, let's think, we want x or cosine of x dx. Well, if we write u, the next thing is going to be to find the du, which means if we differentiate, we're going to get 1 power less. So we would like that, to get 1 power less of x, which would be 1. So let's do this, x, and then this one would be dx. dv, it's cosine of x dx, so v is going to be integral of cosine of x dx, which is sine of x. So now if I'm using the formula integral of u dv, it's integral of uv minus integral of v du, in our case is going to be uv, so it's going to be x sine of x minus integral of v du, of integral of sine of x dx. So no problem, x sine of x I copy it, and then integral of sine of x is negative cosine of x, so plus cosine of x, it's indefinite integral, so it's plus c. So how did we choose our u and dv? Well, I try to use the u so that it's getting a power less. Just imagine, for example, if we used our u to be cosine of x, our du would have been negative sine of x dx, and then if dv was x dx, v would have been x squared over 2. So the problem would have been our second term would have been minus integral of v x squared over 2, and then du, which was negative sine of x dx, so we would have gotten a more difficult integral as our second term than our original problem. So we want to just narrow it down to something that it's more basic. So let's take a look at another problem. Let's try and see this one. Integral of x squared e to 4x dx. So again, u equals, let's use the x squared because du is going to be 2x dx, so it's going to be 1 power less. And dv, it's e to 4x dx, so v, it's integral of that, which is e to 4x over 4. So integral of u dv, it's uv minus integral of v du. So it's going to be x squared e to 4x over 4 minus integral of 2x times e to 4x over 4 dx, sorry. So what happened, let me rearrange them. So it's going to be x squared e to 4x over 4. 2 and 4 cancel, so I can put minus 1/2 integral of x e to 4x dx. So what happened? Our original problem was x squared, and now we have 1 power less. So our choice of u and v was perfect. So now let's do the same for this one. U is x, du is dx. dv is e to 4x dx, so v is e to 4x over 4. So now again, it's x squared e to 4x over 4. I just copied this term, the first one. I just copied here. And then minus 1 over 2. We saw that when we integrate by parts, we get 2 terms. So I'm going to open a parenthesis, and it's going to be uv, so it's x e to 4x over 4, minus integral of v e to 4x over 4 du, which is dx. So we get x squared e to 4x over 4 minus 1 over 2, well, 1 over 2, 1 over 8, x e to 4x, and then plus 1 over 8 integral of e to 4x. So I multiply these two, that's how I got 1 over 8, and then I end up only with integral of e to 4x, which is e to 4x over 4. Plus c again, so x, I can write e to 4x common factor, and then I can say x to the second over 4 minus x over 8 minus 1 over 32 plus c. And we could have arranged them in other ways, of course. Let's see what happens if we have an integral like this one. Well, we have the two functions e to the x, and the other one is cosine of x. So let's choose u to be e to the x. So du is e to the x dx, and dv is cosine of x dx, and v is integral of that, so it's sine of x. So in our case, it's going to be uv, so it's e to the x sine of x, minus integral of v sine of x, du, which is e to the x dx. So it seems like we are getting a similar integral, right, like the original one. It's just e to the x, but I don't have cosine, I have sine. So I'm going to do the integration by parts again. So u equals e to the x, so du it's e to the x dx, and dv it's sine of x dx, so v is negative cosine of x dx. So in other words, we're going to get e to the x sine of x minus, again, we saw that when we integrate by parts, we get 2 terms, so this minus is going to be in front of 2 terms, so I'm going to open parentheses. uv, so it's e to the x, times negative cosine of x, sorry, here I shouldn't have put the x, e to the x negative cosine of x, minus integral of v, negative cosine of x, du, so e to the x dx. So e to the x sine of x, then I have negative, positive e to the x cosine of x, negative, 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 so minus integral of e to the x cosine of x dx. So what do we notice? Our original integral, which is this one, was obtained here as well. So in other words, if I write our original integral as I equals e to the x sine of x plus e to the x cosine of x, I'm going to write minus I because it's the same quantity. So I rename this one as I. What does that mean? If I move the I here, or I add an I get 2I equals e to the x sine of x plus e to the x cosine of x, or I is 1 over 2 e to the x over 2 sine of x plus e to the x over 2 cosine of x. Or in other words, the integral that we had to calculate, integral of e to the x cosine of x dx, it's e to the x over 2 sine of x. I can actually factor out e to the x over 2 sine of x plus cosine of x plus c. So when we have trigonometric functions like this one, we actually, that's not the problem that I solved, we actually move in circles, right? And when do we stop? We stop when we obtain the same integral. That doesn't happen when we have polynomials instead of e to the x, because the polynomials are just decreasing the powers. Now there is an acronym that might help you decide which one is the function u. Here we start with finding u. So the acronym is LIPET. So how do we choose u? So we choose u like this. We choose the logarithmic function if we have a logarithmic function. If we don't have that, but we have an inverse trigonometric function, then we will choose that. Or we'll choose a polynomial if we have a polynomial first. We use exponential if we have an exponential, and just at the end we use the trigonometric one. So if you think about it, the problem that we just did here, it had an exponential, and it has a trigonometric one. So what did we choose as our u? We chose the exponential function. I hope this helps.